Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 1st. I'm Mark Sponsler, and I'm your host. Tonight we'll be talking about, of course, significant wave heights, sea level pressure, jet stream winds, and all the things that help create storms in the Pacific Basin. And we'll even take a look over in the Atlantic Basin at a very strong hurricane over there. And then, of course, we'll take a long-term look at the MJO, Bad and Juliet oscillation, and, of course, maybe even a longer look towards El Nino or La Nina, or what's going to go on 6 months to maybe even a year from now. All right, let's get into it. First off, we'll take a quick look at the Pacific Basin, just a general idea of what's going on. And we see a much improved pattern compared to a week ago, or maybe even 2 weeks ago. Small gale under New Zealand, producing 41-foot seas, aimed off to the northeast. And that is the third, I believe, in a series that's been going on. Here's remnants of number 2, remnants of number 1. And there's been activity in the North Pacific as well. So things are looking much better than they were previously. All right, let's get into it. First off, take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help them direct their track. We're looking for a trough, like pushing the jet to the northeast, sort of like there, but there's a very weak trough. You see just not a lot of winds. You want to see at least, let's say 100 or 110 knot winds. Instead, we're seeing 80, 90 knot winds pushing the northeast. So this is really the fading remnants of a stronger trough that was under New Zealand. That is, or at least was supporting gale development. And over in the southeast Pacific, we see a big ridge. That is, the jet is pushing south. Now, what a trough does, you can see it there, helps create a counterclockwise flow aloft, and in the southern hemisphere, clockwise flow. In the southern hemisphere, that is the sign of low pressure. And of course, low pressure in the upper atmosphere manifests itself down at the surface. Low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So that's why we're so concerned with the jet stream and troughs, because that really is the essence of what helps create storms and surf. All right, so we'll roll this out. We see our trough is pretty much fading out as we get into Monday. Remnants of it hanging on. I mean, it actually, form-wise, it looks pretty good, but there's just no wind energy associated with it. So that just doesn't do anything to support gale development. If anything, we see a ridge starting to build. When you get this sort of split jet like this and this dead air in between, that generates high pressure, and that pretty much stomps on the storm machine down there. So that doesn't look good. So we see a ridge under New Zealand, a big ridge in the southeast Pacific, remnants of a trough over the central South Pacific, and even that kind of fades out. And as we get into, well, here we are Thursday, we see a ridging pattern just completely taking over. The ice line is about, Ross Ice Shelf is probably about 63 south. The ridge pushes south of the ice line, so there's just really no hope there, and that pattern continues on. We'll just sort of roll this out, see what happens. Now here we get into, whoops, so where were we? There we are, Sunday night. Now this is the interesting part. It looks like a trough is supposed to start building a week from now. If you believe the model 180 hours out, that's a fool's errand. But, well, just for the fun of it, it looks like a trough might start developing in the Tasman Sea a week from now. And maybe that'll give us another little bit of hope. But by that time, we're kind of hoping the North Pacific kind of starts waking up and does something. In fact, there's already been some activity up there, but nothing really stellar. So we're going to focus on the southern hemi for now. So let's take a look at the surface now. And of course, we thought that trough that was right in this area was pretty much dead. But as you see, there's a gale. In fact, it's a storm. 50 knot winds. Not a huge one, but hey, we'll take it. 50 knot winds south of New Zealand, getting traction on the ocean surface. We know it's generating seas. That's a good thing. So we get into Sunday night, 55 knot winds, building if anything. So the jet stream doesn't tell the whole story, but we kind of think normally it does, but there's a little bit of a disconnect. Anyway, into Monday, 50 to 50 knot 55 knot winds, aimed pretty well to the northeast. This is looking good. Then starts fading Monday night. Still, bit of fetch, 35 knot fetch, but that only gets you about 13, maybe 14 second period swell. That will pretty much decay on the, from about here, maybe 5,500 nautical mile journey up to California, lesser to Hawaii. But this is almost east of the Hawaiian swell window. Then it fades out, as expected as we get into Wednesday. Look at that, big high pressure, wind pushing hard to the south, not to the north. You can't get swell if the winds aren't pushing at you. And you get the general idea here, just a very non-favorable pattern setting up. Now this is interesting, sort of a backdoor trough forecast a week from now. This is a Saturday night, 45 knot winds aimed to the north. And maybe, typically the model tends to overhype these backdoor lows a little bit. So, and there we are at 180 hours out. Hey, remember we said there was a trough developing in the Tasman Sea forecast a week out, and you see some fetch starting to develop. So maybe, just maybe, that'll work its way to the other side in New Zealand, east of New Zealand, and we'll get something from it. All right, let's go take a look down at the surface. So we're going back in time. We're going back to Tuesday night, the 28th of August. And why? Well, that's when the first of a series of gales push under New Zealand. You see, generate a small area like 30-some foot seas, building to, it says 41 feet, but it's such a tiny area. And the thing is, it's either aimed to the east or to the southeast. That does nothing for us. So, but that just sort of what it does is these sort of gales, they'll rough up the ocean surface, generate seas, 40-foot seas are nothing to sneeze at. But what happens is when you get additional fetch pushing over that roughed up surface, those winds or, another gale will get good traction on that already agitated sea state and then turn around and blow up equally as large, if not larger seas, if it can sustain even a decent amount of wind. And that's what happened as we got into Thursday. Instantly, a tiny area, 40-foot seas, building to 44 feet. And what was that? Yeah, 43, 44-foot seas into Thursday evening. So this is Thursday a little over a week ago. And aimed off to the east, 40-foot seas. And so there is some little swell that's going to arrive from that one. And then we got into Friday, and here's yet another gale pushing over the doubly agitated sea state under New Zealand, generating 40 seas up to 44-foot seas, and then sort of fading from there, but lifting more to the northeast. The better it lifts to the northeast, then it pushes the swell train towards Hawaii and the U.S. West Coast. That's our prime forecast area. That one fades out, and then where we are now, we are Sunday morning, and here's yet another one developing under New Zealand. And then as of 18C, see what is that? Back to 41-foot seas. So what's this, 4 systems with 40-foot seas? Now none of them are particularly big, but watch this one. It lifts more to the northeast. What's that? 43-foot seas, 44-foot seas, 44-foot seas. 45-foot seas forecast about midday Monday morning, lifting well to the northeast, and then finally starting to fade on Tuesday. All right, so the point being, if your storms are moving to the east, you get not so great swell. The better to the northeast, the better. And so this series of 4 systems, first one southeast, second one to the east, third one to the northeast, fourth one better to the northeast. So the net result should be a progressive pattern of 3 different swells, all from this, favored New Zealand angle, getting progressively stronger, and aimed more towards California and Hawaii. The downside is when they get off in this region here, well, there's Tahiti up in here, and the Great Circle path goes like something like this. So then you get blockage by Tahiti. That sort of knocks down the size a little bit, knocks out the number of waves per set. But hey, this late in the season, any southern hemi swell we take, we'll get it, especially seeing how August has basically been dead. So, hey, we got some surf. This is not a bad way to be. All right, so then we move out. We're at Wednesday of next week, and then the expected result is, and you see here the ice line, where is it? It's up to almost 61 south, and the lowest it goes is about 64 south, something like that. So a lot of the South Pacific is just choked off by ice this time of year. Not surprising. We saw on the models, not a whole lot happening. We just see, look at this, a little tiny fetch right here, and some seas in the nearly 30-foot range, maybe a little pulse, certainly for Tahiti, and maybe a little bit for the Hawaiian Islands if that materializes. Oops. And so then we are 180 hours out. Remember, there's that trough and supposedly seas building out in here. And look at this. There's a pretty intense storm with 48-foot seas forecast pushing under Australia. It'll be interesting to see whether this makes it to the Pacific and blows up. Probably not. Given it's 180 hours out, this is all just complete nonsense, but something to watch, tease ourselves a little bit. And a quick look to the North Pacific. So there was a tiny, we won't even call it a gale, a low pressure system developed in the Gulf of Alaska, created a tiny area of seas. What's this? 8, 9, 10, 11, yeah, 12-foot seas. Building, you see it got more organized. It actually got like 35 knot winds. Seas pushing 18 foot, aimed at the Hawaiian Islands. That continued into Thursday, falling south. You can actually almost see the swell line hitting. I think it actually hit today. Now here's the one of more interest. Is starting on, when was that? Friday night into Saturday. Little gale developed here over the North Dateline region. Here's the Dateline here. Here's the Aleutian Islands. So we generally label this the North Dateline region as compared to the Northern Gulf, the Central Gulf, or the Central Dateline region. Anyway, you get the idea. Seas built, it pushed to, it says 37, we'll give it 36 feet, aimed pretty well off to the east. Small swell expected to result for Hawaii. By small, I mean small. And the U.S. West Coast, yeah, something mid next week in the maybe head-high range for a day or so. This system faded out as of now, right? Yep, as of now, and it's all but gone. And then the forecast for the coming week for the North Pacific. Now notice, there's a little tropical system trying to develop here south of Baja. Nothing particularly big, nothing particularly interesting. You can watch the swell propagating towards the U.S. West Coast from this Gulf system. And this tropical system supposed to build, it looks a little bit better here than what it does if you look. We'll look at some other data. But you get the sense that, yes, Southern California could get some tropical swell from this. Maybe. I mean, it's, well, wait till we get to the forecast. Anyway, moving out, another little low forecast for the Northern Gulf. I mean, this is like wind swell land sort of thing. What is that? Maybe 14-foot seas forecast. And that's it. Wind swell for maybe next weekend. And you get the sense, looking at this, that the North Pacific is trying to come online. We're not going to get into all the details of tearing apart the jet and all the surface models, because it's just, there's nothing really to look at yet. But you see this steady motion of systems, you know, like the jet stream appears to be waking up, and things appear to be getting better. We're not there yet, and who cares, because we got a series of southern hemi swells coming. But this is all good. You know, we're starting to get energy again coming from both directions. Hey, can't be too bad. So then let's go do an inspection on wind swell, because all we've been talking about is longer period ground swell now. All right, so right now, pretty much a weak pressure pattern, no real east fetch. I mean, you need at least 15 knot winds over a couple hundred nautical miles to generate some, at least like 8-second period wind swell. Nothing east of Hawaii, nothing really off the California coast this morning. And you get into Monday, a little bit of a building fetch, and you get the sense that down here, yeah, some weak tropical system might be generating some fetch relative to Hawaii, but nothing really significant. We get into Tuesday, you can see our tropical system starting to creep into the image here. A little bit of east fetch east of the Hawaiian Islands, mainly targeting the Big Island, and even that pretty weak. No real fetch along the California coast. Get into Wednesday, and then we see a little bit of high pressure trying to organize. Here's that, remember that little low forecast for the Gulf of Alaska? 35 knot winds, tiny little system though. Maybe wind swell for California, a little bit of wind swell for the Big Island. And look at it, the fetch dissolves off of California. I mean, this is pretty typical. High pressure that's in the Gulf of Alaska in the summer months, as you get into fall, it starts dissolving. That's how you get low pressure, you know, starting to build. We see it, 25, 30 knot winds in the Gulf, maybe generating something. There's our tropical system on Thursday. You get the idea. A little bit of more fetch relative to Hawaii. Get into Friday, another low pressure in the Western Gulf. Not swell worthy yet, but the pattern appears to be amplifying rather than dissipating. Tropical system gone. You see some wind swell. So we're talking about maybe wind swell for next weekend for the California coast, wind swell for the Hawaiian Islands, low pressure of some sort in the Gulf of Alaska, but oh, and then here comes high pressure. You see this high pressure right here? wind flows clockwise around the high, shunts the low up to the north, get the normal pressure gradient off of California, building, here we go, Sunday morning, 30 knot north winds, wind swell looks to be the call, and wind swell for the Hawaiian Islands. Roll this out to 180 hours. Full-time summer-like pattern now with the pressure gradient, north wind swell for at least central and north California, and then also fetch working its way the whole way over the Hawaiian Islands, so wind swell on east-facing shores. So all in all, not a horrible pattern, certainly a variety of swell sources to choose from. Southern hemi swell, North Pacific swell, local wind swell, maybe hurricane swell. Yeah, you're gonna have to pick carefully, and spots that are exposed to all this stuff, you probably want to stay away from them. 4 different swells from 4 different directions. It doesn't normally work out too well, especially if some of them are like 18-second period swells. It turns into a mess. All right. Here's a quick look at the tropical system south of Cabo San Lucas. Tropical storm Juliet, 50 knot winds. What's that, like 55 mile an hour winds right here. Building up, it blows up to maybe forecast on the 3rd. So what's that, 2 days from now? Tuesday, 85, 90 knots. So let's say 100 mile an hour wind, something like that. 1.15 knots times 1.15 equals miles per hour. But you see, it's not like pushing well to the north. It's sort of like to the northwest. Yeah, some sideband swell if all this happens for exposed breaks in Southern California. But, 12-second period or something. That's not that big of a deal. The southern hemi swell, well, this will get there first before the southern hemi swell does. So anyway, you get the picture. Now this is what a real hurricane looks like. Solid eye. They call it the stadium effect. You look like you're sitting up here along the eye, and you can look down into the eye and see the ocean surface down inside the eye. This is a very well-developed storm, and by well-developed, we mean it's not huge, doesn't cover a lot of area, but extremely strong. Peak winds estimated at 185 miles per hour. That was the 18Z update this morning. Very strong. Everyone along the Florida East Coast, very concerned. Folks in the Bahamas, North Abaco Island, and Grand Bahama Island, I hope everyone has evacuated. This is not a good situation at all. The eye's making a direct hit over landfall here. It's not good at all. The one thing is that just maybe because the water's so shallow, it'll help break up the storm surge a little bit. If this system, so the current projection, let's go take a look at that. So the current projection has been pretty stable. We've been mapping just about every one of the updates here. Originally, this thing was supposed to come on shore somewhere in the Fort Pierce area, and then little bit at a time, there was a high pressure ridge up here that was preventing this system from recurving. That high pressure is theoretically breaking down. The forward speed on this storm is slowing. So the idea being is it'll get close to the Florida coast. We actually did some analysis, and it made it to within 48 nautical miles of like Cape Canaveral, Cocoa Beach area, and pretty much the same on down the coast here. Hurricane force winds extend out. I think it's like 40 miles from the center. So this is a small storm, very strong, but small. So theoretically, you would barely get hurricane force, strong tropical storm force winds raking the east coast of Florida, and you can see the projected path, just the same deal the whole way up the U.S. East Coast up to Cape Hatteras. But the point being, this path is not guaranteed. You look at multiple models, they're all pretty well clustered around this outcome. But if the center is only 48 miles off the coast, if it deviates even 15 miles to the west off course, the net result could be pretty catastrophic for locations along the central Florida coast or so. So that's why we're watching this so close. And the fact that it has 185 mile an hour winds, you just don't see that very often. So it's worth making a mental note, maybe taking a snapshot of this file, saving it for your files, just for posterity's sake. And with that, let's go take a look long term. What's going on with the Madden-Juliet oscillation and El Nino in the Pacific Basin? And the interesting part about this too is typically when you have some sort of flavor of El Nino in the Pacific, you have a very lackluster Atlantic hurricane season because El Nino basically creates a bunch of shear over the Atlantic and just rips the top off all the storms. So if we have a storm with 185-mile-an-hour winds off of Florida at this time of year, that pretty much tells you what's going on with El Nino, like nothing. So as usual, we like to look at winds over the equatorial Pacific, specifically in the West Pacific, and even more specific than that, the area we call the Kelvin wave generation area. So this is the West Pacific here, East Pacific here. This is the equator, the dateline, 180 degrees right here. That's New Guinea. Kelvin wave generation area from 170 west, 5 degrees north and south of the equator. So just this over to 135 east. So you just draw a little box in your mind right there. And this is the area that we're always concerned with because it gives us clues as to what's going on with El Nino. So right now, this is data from the TAO buoy array, series buoys strung across the equator. We see, and this is 5-day average winds. So we see winds, yeah, blowing out of the east, pretty strong. That's pretty normal for this time of year. But they only make it to not even the dateline. Yeah, a little bit on the dateline. There might be some data outages right here, hence the gap. But then you get into the far West Pacific, you see actually some westerly winds. So that gives you a clue, but it's the anomalies. Is this stronger or weaker than normal for this time of year? And so anomalies tell you that. Differences for this time of year. And we're just looking at the arrows and we go, there's not really arrows doing anything. So kind of normal in the East Pacific, West Pacific, a little bit out of the west. So maybe that could tell us that we're in a weak active phase of the MJO in the West Pacific. It's west anomalies that we're looking for because that's reverse of normal. And normal, if you have trades over here, then that's just, quote, normal. Or if they're stronger than usual, then that might be the inactive phase of the MJO. But when they have western anomalies, they're reverse of normal. That's the active phase. And basically, the MJO is like this ball of low pressure that travels the active phase from west to east across the Pacific. When it does that, creates cloudiness, creates weather, imparts energy up into the higher levels of the atmosphere, feeds the jet stream, and the jet stream, of course, feeds the storm track. And then if you have storms, you get swells, and you get the idea. All right, so weak active phase in the West Pacific, maybe. Let's go look at more data. So let's go look and see what winds have been doing for the past 5 days. There's South America. There's Central America, Mexico. Right there, New Guinea. All right, so the equator's there. Dateline's there. Oops, dateline's there. Kelvin wave generation area, generally here. And all these images are exactly the same. It's just day by day. If you see reds, that's westerly anomalies. So weak westerly anomalies. That was on the 26th, 27th. A little bit stronger on the 28th, a little bit stronger on the 29th in the Kelvin wave generator, a little bit stronger on the 30th. So, yeah, it kind of looks like a building active phase of the MJO. Now, you see all these patches of red everywhere else? It doesn't matter. That's not MJO related. It's literally right on the equator and literally in this box here. That's where we're really interested in. That's when you get the most transport of energy to the jet stream, either in the North or South Pacific, and the best odds for feeding the jet stream. And not real surprising that because this is happening, the South Pacific is starting to blow up, and at the same time, the North Pacific is too. All right, let's keep digging. The wind forecast for the next 5 days. Well, okay, so what's this chart all about? Oh, here we will put it this way. All right, so the Kelvin wave generation area, well, the Pacific is from like 135 east to about 90 west. Dateline's right there. So Kelvin wave generation area, basically between these two tick marks here. And past performance, look at the dates here, are straight up from there. See, and the reds are westerly anomalies. So this is the whole planet on one chart, right? So we see westerly anomalies, kind of weak. Doesn't look like much of a active phase of the MJO, but it's been ongoing since August 12th and is continuing today. And then it looks like it's going to fade out over the next week. But we've had a little bit of a push here, and that's, my guess, is what's trying to feed the jet stream. Now, notice this all started August 17th, and it was only about a week ago that we started getting activity down south. It takes a little bit of time. I mean, it's not instantaneous. You get west winds in the West Pacific, and all of a sudden the jet stream wakes up. It takes 5 days, a week for that energy to start working its way up into the upper atmosphere and up into the north, wherever, to start feeding the chain reaction. So this all looks about right. All right, forecast charts for the MJO, outgoing long wave radiation. There we go. This is from the statistic model. All right, so really, there's South America, Central America, the equators, says EQ, that's the equator, dateline right there. Kelvin wave generation area right there. The blues is outgoing long wave radiation, so that means how much sunlight's reflecting off the ocean surface. Negative values, which are the blues, means cloud cover, which one can assume is the active phase of the MJO. So you look and you go, okay, for the next 2 weeks, looks like the active phase is building. You go, oh great, I'll take that to the bank. We should be in an even better situation in terms of storm development. Then you get to, that's one model, the statistic model. The dynamic model, the GEFS model, says, no, not really true. So even between the models, they disagree. You have to look at multiple models and sort of go, okay, well, what's the path between all of them that makes sense? So the GEFS says, no, if anything, we're just going to be dead neutral. That's probably closer to reality. Phase diagram charts, another way of looking at the MJO. Okay, so assume you're looking down on the North Pole, and that circle is the North Pole. The MJO is on the equator, and it goes from the Indian Ocean, from west to east, over the Maritime Continent, over the West Pacific, over the East Pacific, under the United States, like through the Gulf of Mexico, across the Atlantic, over North Africa, back to the Indian Ocean, round and round. Active phase on one half, inactive phase on the other. So the heavy dot, you can barely see it, it's like right there, is where the active phase is right now, over the Maritime Continent. So Bali, that area. If it's inside this circle, it's very weak. Well, that sort of makes sense looking at the previous charts. Very weak MJO signal. And the forecast is for it to stay. Here's the 3 different possible tracks, all of them basically inside the circle, traveling to the West Pacific over the next 2 weeks. This per the statistic model. Dynamic model says, no, not even that good. It'll just sit there balled up and weak and basically hibernating over Bali. Okay, well, that's not helping us a whole lot. The 40-day upper level model, looking for yet more clues of the MJO. Where is it hiding, right? Okay, you see this sort of, this is as of September 1st, weak inactive phase of the MJO over the Central America sort of thing. And if that's the active phase, the greens are areas favorable for precipitation, the yellows unfavorable for precipitation. So I guess that's the active phase. You get the general picture. It's extremely weak, slowly working its way into Central America through September 26th. Then a equally weak inactive phase sets up in the West Pacific in early October. So the thought being, yeah, probably later September is going to be our little window to support storm development, but not a whole lot of help from the MJO, then fading into October. The 1-month CFS model. Okay, what's this telling us? Same deal, whole planet on one chart, Kelvin wave generation area between these 2 tick marks going up. Here's where we are today. Reds, westerly anomalies. All right, so now look at this. If you saw, well, we'll go up here. The MJO signal says MJO, solid black contour, right? And there's an inactive one because it's dotted. And there's the active. But you see the MJO has just been exceedingly weak for quite a while. But the good news is you got these westerly anomalies that have just been non-stop in the core of the Kelvin wave generation area. And for this model, are supposed to continue into September 14th, then weaken a bit, but still solidly there. And I'm purposely ignoring the blue or the purple line here below pass filter, because we're going to get to that in a second in another chart. So here's the 3-month CFS model. It's basically the same as the one you just looked at, except it doesn't hype the reds as much. It's got to be really a very strong westerly winds to get you reds. And this one flips the direction. Past performance is down here. The forecast is looking up. But here we go. So the Kelvin wave generation area between these 2 tick marks looking up, here's where we are. And this sort of because it's 3 months, it gives you a broader brush view, and you see westerly anomalies. The yellows here, yeah, they hang on for about 4 or 5 days. They back off some. But then you look as we get into October, November, almost into December. If anything, they're building, getting more cohesive according to this model. And that's like, really? Interesting. You know, I thought El Nino was dying. I thought, you know, I mean, this kind of doesn't make sense. Here's the MJO. Here is moderately strong, the solid red contours, moderately strong active phases. Here's a moderately strong inactive phase. And look at this, just no MJO signal at all. I mean, these aren't even, I mean, we're calling them active, inactive, active, inactive, but they're like so weak, it's not even worth considering. Okay? But you have persistent westerly anomalies in the Kelvin wave generation area, and that's exactly what you want to have. And if you're in an El Nino pattern, this is exactly what El Nino looks like. But we're not in El Nino. We know that. El Nino is like dead. If anything, we're heading towards La Nina. So this is kind of a mixed bag. But we said we'd hold off on the low-pass filter. Let's take a look. Now, this is the really interesting part. Last winter, or last spring, we had 2 contour lines. So this is basically like a persistent low-pressure bias. And that's exactly what you want in the Kelvin wave generation area to feed storm development, especially when you're getting into fall and winter months. And we thought, like back in here, that this low-pass, low-pressure bias was going to die. It was going to move off over. Oh, this is new here. Look at this. This is very interesting. All right, so we thought this guy was going to die. He was going to move to the Indian Ocean, and a dotted contour like that was going to show up over the Kelvin wave generation area. But just as of today, all of a sudden, this means high pressure in the Indian Ocean, deepening low pressure in the Pacific as we get into Thanksgiving with 1, 2, 3 contour lines. Very interesting indeed. If I was just looking at this without knowing anything, I'd go, oh, it kind of looks like El Nino is going to happen this winter. Really? Really? And, you know, I'm scratching my head, and you're going to see why in just a minute when we start looking at surface, ocean surface and subsurface temperature data. And before we leave the MJO thing, just strength of the MJO, okay? So here was El Nino back in 2015. These are the spikes. They don't tell you where. They just tell you the strength of the MJO. And you can see 4 standard deviation MJO spikes active phase in 2015, and 3 standard deviations in late 2017, 2018, and now here we are. Look at how weak the MJO is. It's all but dead. If you're in an El Nino, you would expect to see these things spiking up like that or higher. We're not seeing that. It just looks sort of like the atmosphere has no energy at all. It's all tapped out. All right, let's go take a look in the ocean, because El Nino has an atmospheric component, has an oceanic, a sub-oceanic component, and an ocean surface component. West Pacific here, East Pacific here, the data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. Here are the anchor lines on those buoys. The X's are the sensors on the anchor lines. You get the idea. Use the models, glue it all together, build a profile of what the ocean temperatures are like. So, warm water, 30-degree isotherm. It was actually over at 180, this dark red. It's actually retrograded 2 degrees, about 178 east today. The 28-degree isotherm line holding steady at about 160, maybe 161. 24-degree isotherm line, I think it was back at 125 or 127 last week. So it's made a little bit of eastward progress to 118 today. Interesting. Okay. So how's that compare to normal? Here we go. Anomalies. Differences from normal for this time of year. We have like sort of a stationary Kelvin wave, and a very weak one at that, with barely 2 degrees centigrade anomalies under the date line. So, and it's going nowhere. Brick wall cut off right here. That is at, 150 west. Cool water. Now, the good news here, this was down to like 4 degrees below normal last week. It's moderated significantly. We've started to see some warm anomalies rebuilding here, but basically the whole East Pacific was full of cooler than normal water, or at least a little bit below normal. That would be a sign of La Nina, not El Nino like the CFS model's been saying, but that appears to be dissipating a little bit. I don't think this Kelvin wave's going anywhere, so it's kind of hard to figure out what's going on. So we'll just leave that there. Let's go take a look at more data. When in doubt, look at more data, right? Okay, well, here's another model. Same raw data. It's basically saying the same thing. Warm water stuck on the date line, subsurface down 200 meters. Cool water, a lot of cool water off in the West Pacific. So even if you got a big old strong active phase of the MJO, a bunch of blowing west winds, there's no warm water here to create yet another Kelvin wave. And then we have our cool pattern here that looks suspiciously like La Nina in the East Pacific and filling half the Pacific Ocean. Okay, that's not particularly good. Sea level anomalies, just another way of gauging where the cold water is and the warm water is. Jason 2 satellite, strip out all the waves, strip out the wind waves, strip out the tides. You're looking for a little bump on the ocean's surface. 5 centimeter bump, positive numbers here. Not even right on the dateline, but on the dateline, but not on the equator, sort of straddling either side of it. But that suggests warm water at depth, of course, expands a little bit. That creates the bump on the ocean surface that the satellite's picking up here. Of more interest, -5, -10 centimeter anomalies in the East Pacific, again suggesting cold water contracting, creating a bit of a divot on the ocean surface, like a 1,500 or 2,000 mile long divot, suggesting cold water here where warm water should be if you've got El Nino, and warm water on the dateline, but not going anywhere and pretty much locked in place. Certainly doesn't look like El Nino. Upper ocean heat anomalies, West Pacific here, East Pacific here. We've seen this before. So this is Kelvin waves. This is like what, Kelvin wave number 3, I guess it was, back in September last year, a year ago. Pretty good Kelvin wave. Made itself the whole way across the Pacific. Warm water. The reds are warm water. Look at the, oh, you can't see the scale. Here's the scale. We don't need the absolute values here. But you get the idea. Kelvin wave going from west to east, created by the active phase of the MJO. Kelvin wave number 4, again in January, March of this year, making it just barely across the Pacific. Notice upwelling phase of the Kelvin wave cycle. And now look at this, boom, boom, boom. All these like little micro Kelvin waves, if that's even, it's just noise basically. It's steady warm water holding, sort of getting stronger, weaker, stronger, but not making any eastward progress. Cool water, if anything, building in the East Pacific Ocean. Cool water is warm water here. Cool water building in the West Pacific. This is the only place left for warm water to go, so it's just sort of sequestered in a bubble sitting under the dateline, okay? And that warm water is probably evaporating, creating some lift, but it's not going anywhere. Maybe this is what the model is picking up on and just going, well, okay, it'll be an area favorable for precipitation and low pressure development on the dateline. At least it's better than La Nina, right? But this is not El Nino. All right, sea surface temperatures. It's not even what's going on, not what's going on in the atmosphere in the Kelvin wave generation area, not what's going on under the ocean, but on the ocean surface. If you have warm water on the ocean surface, that creates evaporation, and that, helps feed the jet stream, all that kind of stuff. Well, what we see is cool water along Peru, Ecuador, radiating along the equator out to at least 160 west. Now, the good news here, this is not nearly as pronounced as it was a week ago, and that wasn't nearly as pronounced as it was 2 weeks ago. I mean, it looked like a full-on La Nina was developing. This looks like, well, we got a lot of warm water to the north. We got a little bit of, so this warm water here was almost completely gone at 10 south a week ago and 2 weeks ago. It's trying to make a comeback, but there isn't a whole lot there to help it. But at least it's kind of neutral looking. So, all right, that's that. Let's keep going. Sea surface temperature trend for the past 7 days. Now, this doesn't look good. Here's the equator. Blues cooling. The temperatures are getting colder all the way along from right here. So the main official, the Nino 1.2 region, sort of a noisy area, is right in here. Okay. The official El Nino monitoring region, the Nino 3.4, is from here, 5 degrees north and south of the equator, from 120 west to 170 west. And what do we see? See a bit of cool water, pockets of warming water, but this has been going on for quite a while. Suspicion is temperatures are still cooling. And yeah, you see all this warming all around here. Great, that's all wonderful. But that's not what feeds the MJO. It's not what feeds El Nino. It's all focused exactly on the equator. Kelvin wave generation area right here on the equator. The El Nino monitoring regions over here. They play together. They feed each other. You get active phase of the MJO here. Creates west winds, takes warm water here, pushes it to the east. It falls to depth, travels as a Kelvin wave under the equator, then eventually, if it's strong enough, erupts off of Ecuador, advects to the surface, creates like a warm slick, and then that warm water travels off this way. But when you see cool upwelling on the ocean surface or cooling temperatures, that's certainly not El Nino. All right, and then the backed off view. I mean, this clearly, to me, looks like La Nina. See cool water. If it was El Nino, you see warm water building right here, and we're going to show you something in a minute. But no, we see cool water, and this is the August time frame, and it's been this way for a month now. In the East Pacific, almost the whole way to the date line, warm water north and south. It sort of looks like La Nina building and the remnants of El Nino dissipating around it. So we created this little tool, and we just added this to the El Nino monitoring page, historical animation. Let's see. Okay, we got that in here. See, hold on a second. So what we did is we went to the high-res sea surface temperature anomaly site here. You see the link. And we grabbed the August 1st view and it was like December 20th view of every year since, so, you know, as early as how far did it go back here? I think we go back, well, hang on. Here we go to 85. And the idea was just get a sense of what were the water temperatures in August, and specifically in this area, and then how did they morph as you got into December? So in 86, you see, kind of mixed, cool. By December, it was almost like sort of a Madoki El Nino of 86. 87, hey, there's a definite El Nino in August. But it kind of died in December of 87. And then we went into full-bore La Nina in 88, holding into December of 88, 89. You get the idea. And what we're looking for now is things that look like today. And we made a little chart here. Hold on. So just for laughs, here is what a real super El Nino looks like. 97 in August. Look at how warm the temperatures were here. And look how they morphed into December of 97, filling the entire equatorial Pacific and especially off of Ecuador with very warm temperatures. All right. And then after that, the evolution from August of cold water to cold water filling the Pacific Basin in 98, and that basically hanging on in 99 and 2000. You get the general idea. Then we get into, where are we looking for? 2005. So we'll just step through this. So here is one year that sort of looks like we did in August. And how did it evolve? Turned into a full-bore La Nina in 2005. And then 2007 was another one. Here we go. Now this is more drastic than we are today. And how did it evolve? Into a full-blown La Nina in 2007. And then we're going to step through a couple others here real quick. 2013. So here is another one very similar to where we are today. And how did it evolve? It just kind of went neutral, didn't do a whole lot. And then 2016 was another, so we'll go there. Oh, by the way, there's your El Nino from, let's go, started August 2015 into December 2015. And then 2016, this is more pronounced than where we are today. And how did that evolve? Yeah, into La Nina. So you get the idea, and we'll just roll this out into, where are we today? 2019. So there's where we are today. So the question is it going to go warm, or is it going to go cold, or is it going to go neutral? Hard to say just by looking at the models. But anyway, you guys can play with this, get an idea of what's going on. It's out there on the site for you to look at. Sea surface temperature data in the Nino 1.2 region, the area right up there by Ecuador. Temperatures today, almost starting to work their way back to neutral. A third of a degree, 0.353 below normal right there. You can see they were definitely lower than that previously. We'll see whether they stay there, whether they drop off. The official El Nino monitoring region, though, the trend is pretty obvious. 0.417 below normal, 0.4 of a degree, almost bordering on La Nina. You want to be down at half a degree and have to be there for 5 months. The trend definitely downward. Don't see any sense of warm water filling in, building into an El Nino of any kind. If anything, it appears that we're looking at La Nina, from looking at all the sea surface temperature data. You look at the CFS model, though, and it's sort of going, maybe not. So we're going to go real quick here, but we still have more data to go. All right, so what's going on in the atmosphere? Difference in pressure between Darwin, Australia, and Tahiti. The Southern Oscillation Index. When it's negative, that suggests the active phase of the MJO. If it's negative for a long time, it's, like 4 or 5 months, it's suggestive of El Nino. Daily contribution, -14 today. Looking back, it's been all over the place, mainly positive. So that's all noisy. 30-day average, -2.99. And if anything, it's falling a little bit, maybe suggestive of the active phase of the MJO. 90-day average, -6.29. It would need to be down at -12 or 15 to be El Nino. What's the trend? Kind of going up a little. Certainly not clearly indicative of El Nino. If you're having El Nino, it should be pretty obvious by now, this time of year. And this is why we did all that long-winded thing about looking at ocean temperatures in previous years. This is the forecast from the CFS model for the Nino 3.4 region. Today, temperature's about dead neutral. This model, you can see where it's going. It's saying we'll be up to half a degree above normal. Oh, here, we'll slide this over just a little bit so you can see the scale. Half a degree above normal as we get into late October, and holding there, and then going to maybe 0.7 of a degree, 0.65, something like that. So this is borderline El Nino as we get into the late part of the winter. Going, really? Really? Is this model completely out of its mind? I mean, there's no more warm water left over in the West Pacific. Even if you had a bunch of raging active phase of the MJO, there's no warm water left in the Pacific to do anything with. So let's go look at other models real quick. The IRI CPC website, consensus model. What do all these others, like 13 different models here, as of August, what do they say? And you just sort of eyeball it and go, well, at the worst case scenario is some of them say, one says, yeah, full bore La Nina. The others say hovering around neutral or a little bit warmer than neutral. We can actually look at the data down here. August, September, these 3 months. August, September, October, November. You get the idea, but I just look at the first month. August, September, October, November. Going out to April, and here's the model name. Here's all the different data. And they have, from the average for the dynamic models, staying pretty much neutral, borderline, not even El Nino, out as we get into, what was that, April? The statistic models, a little bit more, saying borderline El Nino-ish. So the net result, we'll say, is definitely not La Nina by any model, looking at the averages here. That's good news. Not really El Nino either. The CFS model is probably on the high side. But hey, if it's just neutral, which is kind of what all this says, or neutral biased warm, which is kind of what the CFS model says, I guess, if you ignore the sea surface temperature, just say, yeah, low pressure bias on the, in the Kelvin wave generation, blah, blah, blah. Okay, neutral winter. If that happens, that would be okay. That would be, we'd probably eke out. Now, I don't think that we're going to have a normal winter. I think it's going to be a little bit below normal just because the energy levels, the MJO is weak, everything's very weak. But hey, that's better than La Nina. All right, so the short of it is, wrapping it up, we're actually not in a bad place. We got 3 southern hemi swells on the way. We have a little bit of wind swell for Hawaii that's probably hitting now. We've got a pulse of North Pacific swell for Hawaii and the U.S. West Coast. And there's wind swell in the mix. So there's a lot of swell, and there's maybe some tropical energy that's going to happen. Things are not too bad right now. Long-term outlook, MJO, probably going to stay very weak. Are we going to La Nina? I'm tempted to say yes, but none of the models support my conclusion, so I'll go with neutral with a little bit of a grudge and go okay. Looking at most of the historical data, when we're as cool as we are for this time of year, it manifests itself or turns into La Nina as you get later into the December time frame. But none of the models are saying that, so we'll give the nod to the models. Say, okay, maybe we're going to eke out a normal winter, which wouldn't be too bad. Beggars can't be choosy, so we'll take it. Hey, there's surf going to be coming now for the next couple of weeks, and maybe a better pattern after that, or at least a normal pattern for a while. So things are looking pretty good. All right, that's it for this week. We'll do this again next week. If you enjoyed the video, down this side, hit the like button and ring the bell. If you haven't subscribed, subscribe. You get a notification every time we do this forecast, and then you'll know to come look at it. And you can always visit our website too, stormsurf.com. All the models, everything that you're seeing here is available on the website, and it's free. You don't have to sign up for anything, no subscription or anything. Piles of data there for your use and enjoyment. All right, so do it again next week, same time, same channel. Thanks for watching.